Hyperbolas look a lot like a parabola, but having a mirror image of a parabola. So your center of your hyperbola is always going to start at 0, 0. But again, later when we move this center is going to be HK. You have two vertices, right? And that is sitting right here on either side of this piece of what looks like, I said, two parabolas. And then you have on the inside of your hyperbolas your foci. And again, even though these two pieces aren't touching any part of the graph, this would be your covertex. All right. So similar names to some of the other conic sections that we've graphed. Now, the distances from the center to your vertex has a distance of A, and the distance from the center all the way to a foci is C. The distance from the center to your covertex is B. And now, even though, again, the covertices are not on the actual hyperbola, we need that information because to accurately sketch our graphs, we need to create these two asymptotes. So a hyperbola has what we call two branches, which is the picture, and then two asymptotes. And so when you have a graph that's horizontal axis means that your center, vertices, and foci all fall on that same axis that again is horizontally. And to get this equation right here, or to get your slope, you're going to go up B and over A. And so there's an equation for this asymptote, but to be able to find this, we're just going to use B over A. And then we're going to go downward and have a slope of negative B over A. And what that's going to do is that's going to give us a guide, so that way when we have our vertices, we can then create our branches kind of running along those asymptotes. Now with a vertical, right, so with a vertical hyperbola, that means that, again, you have your focus, your vertex, center, and your other photex are vertically. And so your branches are going to open up and down around those. And again, this is going to be my covertex. Right. And the same values apply. From the center to my vertex is the value of A. From my focus to my center is the value of C. And to my covertex is the value of B. And so again, if we are going to try and find our asymptotes, right, now the vertical value here is A and the horizontal value is B. So now your slope is going to be the opposite. It's going to be A over B, or your slope is going to be negative A over B. So it just depends on which is your vertical and your horizontal to create the slope. And again, that will help us give us this guide, and again, it needs to be dashed so we can run our branches. So let's fill in the blanks over here. Right. So the distance from our center to our vertex is A, to the other side of the rectangle is B, and to the focus is C. Right. Now with your hyperbolas, you have your standard equations for hyperbolas. We're going to skip straight to what it looks like when you have a center that is different than 0, 0. All right, because again, if our center is at the origin, we would just put zeros in here, and we would have an x squared and y squared. Similar to ellipses, your value here is always a 1. But now, when you look at your horizontal graph, the denominator is going to stay the same. It's always going to be a squared minus a b squared, and then the change will happen in the numerator. So look at the difference between horizontal and vertical. The equation is the same in terms of the denominator portion, but I flip-flopped the order of the numerator. And that's going to be important in identifying hyperbolas and identifying how we are going to be graphing horizontally and vertically. Now your foci, again, which is C units, has an equation. And this one, because we are building boxes with our asymptotes, is actually the Pythagorean theorem. So let's do a few examples. All right, so in this example right here, right, we have our graph that has the x squared minus the y squared format. So when I'm in this format where it's x squared minus y squared, this is going to end up being a horizontal graph, which means that when I graph my branches, I'm going to be graphing like this and putting a focus, my vertex, center, vertex, focus. So I'm going to be graphing something like this, which is on the other side. And so I was just giving myself a little guide so that way I know what I'm trying to graph. Now the other piece is going to be now my a squared and my b squared. This denominator is always a squared, which means that your a value is 3. This denominator will always be b squared, so your b value is 4. Now again, my center is going to be at 0, 0. And what I'm going to do is I'm going to try to graph some of these things. All right, so just like we did with ellipses, all right, I want to start graphing and then I'll identify my coordinates. To do that, I also need to find my foci first. And so that's going to be c squared, which is a squared plus b squared. And in this case, that's 9 plus 16, which is 25. So my c value is just 5. Again, when we do these square roots, we really do get a plus and a minus to let us know go right and left or up and down. But I'm just going to use those values like we did yesterday. So let's go over to our graph. We are going to put our center here at the origin. And again, I'm going to label that. And now because I am moving outwardly, horizontally, my vertex is going to move a units in this direction. So I'm going to put a vertex here and a vertex here. And then my foci are farther inward. They're a farther distance away. And your vertex always opens up and kind of hugs your foci. So my focus is actually just farther. And now I need to think about my covertex so I can start trying to create my asymptotes. My covertex is the value b. And so I'm going to put a little coordinate here. And there's a couple different ways of being able to graph this. All right. To get my asymptotes, I'm using my b value over my a value. And so if I go b over a, I can see I'm kind of creating this little box right here. All right, so if I create this little invisible box from my vertex to my covertex, and then I put diagonal asymptotes through that. Okay. So go through the center and the corners of my graph. This right here is my asymptote that I'm going to need to run through. So when I create my branches, I'm going to start here at my vertex, and I'm just going to make a parabola that kind of hugs those asymptotes on both sides. Right. So again, kind of go close and then run through. Just do the best you can with the branches. And this is what your hyperbola will look like. So my vertices, again, is the -3 and +3, 0. Now my asymptotes, I do need to actually find this actual equation here. And so since I'm starting here at 0, my b value or I'm sorry, my y equals mx plus b general format, I can think about what is the slope of this line that I just created and the y-intercept. And again, my slope in this case is b over a. And since I'm going through the origin, I'm not going to have a y-intercept. So when I come here for my asymptotes, I'm going to have to use that information. Right? So I'm going to create an equation with b over a times x and negative b over a times x, because that's the slope of my asymptote, and I don't have a y-intercept to be able to write. So you can write plus 0 if you want. And then again, I'm just going to look at my graph, and my foci was at negative 5, 0 and positive 5, 0. So this is the technique we're going to use to be graphing our hyperbolas.